In this class we want to talk about the median and quartiles. For a start, the median. Now, if a set of data is arranged in ascending order of magnitude, then the median is the middle value of the set. So we're looking for the middle value of the set. We arrange the data in order. So from small to large, and the middle item is the median. The median, I'll just put the cursor onto the screen. The median here is given by this formula. It's half the number of items in our set. So let's say we've got 10 numbers. 10 numbers plus 1 is 11 numbers. Half of 11 is 5.5. So the 5.5th item is the median. Now I know there isn't a 5.5 item. There's a number 5 and there's a number 6, but it's the one in between would be the median. We'll see how that works out in a second. Essentially what we're doing is just looking for the middle number when we organize in sequence. So let's look at this set here. Find the median of the following set of scores. So we've got 18, 20, 23, 20. So it's small, larger, larger, small, larger, larger, small, smaller again, and very large. So we have this set of numbers. Now the first thing we do is organize them. Here's the solution. We organize them in ascending order. So 18, 20, 20, 23, 23, 23, 24, 27, 29. So there are 9 values. 1, 2, 3, 4, 5, 6, 7, 8, 9 in the set. So there are 9 values in the set. Now we need to find the median. So there's our set of numbers, the ones we've just had. The median, as I said earlier, is given us by this formula. Very simple formula. We take the number here, which is 9 in our case. 9 plus 1, which is 9 plus 1 divided by 2, which is 10 divided by 2, which is the 5th value. Now, the 5th value we count along. 1, 2, 3, 4, 5. So the median value, the middle value, is 23. That's all we do to work out a median, just to get the middle value. I think that's fairly straightforward. Now for quartiles, this is a term you may not be familiar with. A quartile is just quarters. The median dealt with half. It was the middle term, so there was 50% on one side and 50% on the other side. Quartiles, 25% and 75% on the other side. If you have 2 quartiles, it will be a half, 25% and 25%. 3 quartiles, 75%. So it's worked out the same way. Here's our set of numbers again. Now the data is arranged in ascending order of magnitude. Then the lower quartile, that's the first quartile, Q1 here. The first quartile is the median of the lower half of the set. So it's the median of the lower half of the set. So the first quartile is a quarter. It's the same formula almost, except now we've got a quarter. N is the number of values, so it's almost the same as we had just a moment ago. So the lower quartile would be, again, we've got 2, 4, 6, 8. We've got 9 items here, 9 values. So 9 plus 1, 10, divided by 4, 9 plus 1, divided by 4, so 10 divided by 4. So it's the 2.5th value, difficult to say. So it's the 2.5, it's even more difficult to say, value. Okay, so what we've got here is we need to go to 2, the 1, 2, and it's in here. It's in between those two. And what we would do then is simply take an average of these two, which would be 20 plus 20, and no surprise, the average is 20. So that works out the first quartile. The upper quartile, well, the formula is 3 over 4. For the median, it was a half, which would be 2 over 4. For the first quartile, it was 1 over 4. For the upper quartile is 3 over 4. So this gives us the 75%. 75% of the values are less than this, and 25% are higher. So again, n plus 1, 9, 3/4 of 9, 9 plus 1, so it's 30. 30 divided by 4, which is 7.5. Up here, 1, 2, 3, 4, 5, 6, 7, 8. So it's somewhere in here. The answer we're looking for is in there. So we take an average again. So it's 24 plus 27 divided by 4, which is 51 divided by divided by 2. That should be a bigger part. I'm taking an average. Divide by 2. So it's 24 plus 27, which is 51 divided by 2. That's wrong there. So 51 divided by 2, which is 25.5. So the answer here is 25.5. So the third quartile is 25.5. 75% then is under, and 25% above. Then we have something called the interquartile range. Some people use this. It's the upper quartile minus the lower quartile. So it would be Q3 minus Q1. The advantage of this is it cuts out the extremes. It knocks off the ends. So when you have a set of data, some of the extreme values might be what's sometimes known as outliers, just anomalies. So they just knock them off. So to do that, you would use the interquartile range. The interquartile range is more useful measure of spread than the range, as it describes the middle 50% of the data values. So it goes for the middle 50%. So it knocks off any extreme values. If you had the range would be, in this case, 29 minus 18. But that's including the extreme values. The interquartile range knocks that off, takes Q3 minus Q1, and that tells us what the interquartile range is. It depends on what you're using the data for. It depends on what you're trying to establish. But it may be a statistic. Okay, we won't dwell on that too much. Just leave it. Here's a pictorial representation of this. The quartiles divide the set of measurements into 4 equal parts. So we have, on this scale here, we've got the first quartile, the second quartile, the median is in the middle, the third quartile, and the fourth quartile. Now the 25% of the measures are less than the first quartile. So that's the first quartile. 25% are less than that. So if you like, 75% here are above it. 50% are less than the median. And if you like, 50% are above it. The median is the middle term. So half the observations are below it, half are above it. 75% of the measurements are less than the upper quartile. The upper quartile, Q3, so 75% are less than that. And if you like, 25% are above it. 50% 50% of measurements are between the lower quartile and the upper quartile. That's the semi-interquartile range I was talking about earlier. So that would be the semi-interquartile range. 25% down here knocked off. We don't count those, and we don't count the top 25% because they may contain some extreme values, some anomalous values. So to get some picture of how this data is ironing out, sometimes, as I said, researchers for various reasons knock off the bottom 25%, the top 25%, looking at the interquartile range. I've just moved that, put it back, there you go. Right, the median is n, and that's all we need to know. So we've established some idea of what a quartile is. A quartile is a quarter. It's 25%. So Q1, the first quartile, the lower quartile, 25% of the observations are below it. Q2 is the median. It means 50% are below it. Q3 is the upper quartile, 75% are below it. The semi-interquartile range is Q3 minus Q1. That's all we need to know about quartiles, I think. And that also concludes our video. So thank you for watching.